In this video, we are going to see the tutorials problems under the steam power station. So if you are an electrical engineer that you are studying this course in your semester, so don't skip this video. Try and watch the complete video tutorials that I will explain now. So now the first question says, a generating station has an overall efficiency of 15% and 0.75 kg of coal is burned per kilowatt by station. So we are to determine the calorific value of coal in kilocalories per kilometer. So this says this is the final solution of what of the problem. So we are going to see whether it is that the correct answer. The first thing that I am going to do, I have to say using the overall efficiency, which is the same thing as 860, you have to take note that 1 kilowatt hour, it is the same thing as 860 what? 860 kilocal. So you have to take note of that. So I have to say divide it by what? Divided by the calorific value multiplied by the mass. So this is the same thing as saying 860 divided by the calorific value. So this is the calorific value, so I have to say multiplied by the mass. So the mass, it is 0.5, so this is 0.5. Okay, sorry, 0.75. So 0.75. So after then I would say 860 divided by the CV that I'm looking for multiplied by 0.75. It is the same thing as what? As the efficiency, which is 0.15. What is my efficiency? The efficiency, it is 15%. If I divide it by 100, I'll get 0.15. So this is the same thing. I will make this subject of the formula. At the end, I will say CV, it is the same thing as 860 divided by 0.15 multiplied by 0.775. So at the end I will have, if I say it, so now I'll say CV, it is the same thing as 860 divided by this multiplied by this. So I'll get 0.1125, which is automatically equals to 7. I will say CV, it is equals to 7.644 kilowatt kilocal per kg. So this is what? This is my CV. I am asked to find what? To calculate the calorific value of the coal. In what? In calories per kg. So this is what? This is the solution to this question. As you can see, also their final answer is 7,644. So it means our answer with their own, it is the same. So the next question says a 75 megawatt steam power station uses coal of calorific value of 6,400 kilocal per kg. It says the thermal efficiency of the station is 30%, while electrical efficiency is 80%. So we have to calculate the coal consumption per hour when station is delivering its full output. So you have to take note of that. I am going to first calculate the overall efficiency. So I will say the overall, let me say the overall efficiency, it is the same thing as 0.30 multiplied by 0.8 because if I divide this by 100 and also divide this by 100, so this will be equals to 0.24, and it is the same thing as 24%. So the next thing, I've already found the overall efficiency, so I'm to calculate the coal consumption per hour when the station is delivering its full output. So I have to say the coal per hour. Let me say coal per hour. So I have to say the consumption. So this will now be equals to, if you are going to calculate the coal consumption per hour, it is the same thing as saying the power, which is 75 megawatts. So if you are going to find the consumption per hour, you are going to say 775 megawatt multiplied by what? Second in a day. So we have 3,600 second in what? In a day. Then you have to divide it by what? By the efficiency, the overall efficiency, which is 0.24 after dividing it by 100. So I have to say multiplied by the calorific, which is the mass, this 6,400. So I have to say multiplied by this 6,400. So you have to take note that we have KL, which is kcal, which is calorific what? Which is the kilocalories, and we have to take note 1 kilocalories, it is the same thing as what? As 4,186 joule per what? Per kg. So I have to say multiplied by what? By 4,186. So this is the kilocalories. So I have to say forward for the kg. So after then you are going to end, after calculating everything, it will now be equals to the numerator, which is 464,500. Yes, it is million 00. Then I have to divide it by what? By 1536. So this is mega. Mega is 10 raised to the power of what? Of 6. So you have to take note of that. So the next thing that I'm going to do here, I have to just divide this. After dividing it, I'll get 41, which is 992 kg per hour. So as you can see, the next thing that I'm going to do is that approximately you have to take note that either you are going to put 4,186 or you will put 4.186. You can put it the way you want. So you have to take note that kg per hour, it is the same thing as what? As ton. So I will just say approximately this 41 will be only what? Will be only 42 what? Let's say 42 tons. So this is the final solution, and also we get the same as their own. So this is for the second question. So the next question says a 65,000 kilowatt steam power station uses coal of calorific value of 15,000 kilocalories, kilocal kg. It says if the coal consumption per kilowatt hour is 0.5 kg and the load factor of the station is 40%, calculate the overall efficiency. The first one, we are to calculate two things, and also we are to calculate the coal consumption per day. So you have to take note that the coal consumption, let me first say the overall efficiency that I'm just going to find, because I'm going to find the overall efficiency. This is what, let's call this as overall efficiency. You have to take note of 1 kilowatt hour is the same thing as 860. So I will say 860 divided by what? Divided by the the calorific value, which is 15,000 multiplied by 0.5. So where is 0.5? This is 0.5. So I have to say this is the same thing as 860 by 7500. So what shall I going to get? Let me see. So it is the same thing as what? It is the same thing as 0.117, which is the same thing as 11.47%. So this is what we get. But it seems like their answer is different from our own. So maybe they made a mistake, because each step we follow it. So therefore I think there is no way that we made a mistake. So let's try for the second one and see whether we are going to get the answer as the root. So the next thing, it says we are to find what? The coal consumption per day. Coal consumption per day. So I have to first say that the 65,000 65,000 what? 65,000 kilowatts. It says per day. Per day we have 24 hours. So I have to multiply it by this 24. So after then I'll get, let me see. I'll get almost 1,500,000 and what? And 60,000 kilowatt hour. With what? Don't forget I have load factor. Where is it? I have the load factor of 40%. So I have to say multiply that. Multiply it by what? By 0.4. So I will say 0.4. So the next thing that I'm going to do after multiplying, let me see what I will get. Let me say answer multiplied by 0.4. So I'll get 624,000. 624,000. So after then, don't forget, I have what? I have my 0.5 for the call. So I have to multiply it by the call, which is 0.5. So after then, I'll get, let me say, multiplied by 0.5. So it will become 300 and what? And 12,000 kg per day. Yeah, so therefore my I2 will now be equals to 312 approximately, which is kg. It is the same thing as what? Tons. So I will now say tons per day, which is tons per day. So I think we got this, but we did not get this. So maybe they made a mistake in this first one. But if one of you realize that it is not a mistake, so you can drop in the comment section. So also we are going to the next question, which says that a 60 megawatt steam power station has a thermal efficiency of 30% if the coal bond has a calorific value of 6,950 kilocal per kg. So we are to calculate the consumption per kilowatt hour. So this is very simple. So I have to say the coal, let me say coal powered per kilowatt hour. It is the same thing as, don't forget, 1 kilowatt is the same thing as 860, and I have to divide it by what? By the efficiency, which is this percent multiplied by 0.3 and also multiplied by the calorific. This is the calorific value. I have to say 6950. So it is the same thing as 860 by what? By 2085. And it is the same thing as the coal per kilowatt is the same thing as 0.413 watt 30 kg per kilowatt hour. Yes, we already get it. So the next thing that I'm going to do is that the coal per day at full load. So you have to take note that the question that we solve here, it says coal consumption per day. So we are going to calculate the coal consumption per day, the same thing. Coal consumption per day and also coal consumption per day. But you have to take note of the difference. The difference is that the first question we have a load factor, but the second question we don't have any load factor. So I have to say this 60,000 watt kilowatt multiplied by 24 as usual. After then it will give me what? But since I did not have the load factor, so I'm just going to multiply it by also the 6,950. So I will now say, okay, sorry, not 6,950. I'm so sorry of that. I'm going to say the final coal that I find, coal per kilowatt, which is in what? Which is, it has its unit in what? In kg. So I'm going to say 0.130 kg power per kilowatt hour. So it is the same thing as well. It is the same thing. Let me calculate it and see what will I going to get. 60 times 10 raised to the power of 3 multiplied by 24 times 0. Okay, let me see times answer. So I'll get 594.7 what? 0.7 tons per day. So did we get the right answer? No, they get 238 tons per day. So I don't know the problem, or maybe it's the same thing. Maybe they have some mistake, but I don't know, because I follow the right way to solve it. But if you realize there is another way that will get the answer, but unfortunately, maybe they are mistaken. So let's move to the next question. So the next question says a 25 megavolt top alternator is working on full load at power factor of 0.8 and the efficiency of 97%. Find the quantity of cooling air required per minute at full load, assuming that the 90% of the total losses are dissipated by the internally circulating air. It says the inlet air temperature is 20 degrees Celsius, and the temperature rises is 30%. So you have to take note of that. The temperature rises, it is what? It is 30%. Given that quantity heat of air, it is 0.4, and that 1 kg of air, it is occupies 0.8 meter cube. So it's occupied which is the volume meter cube. So the question, it is asking that we are to find the quantity of cooling air per minute at a load. At a load. So you have to take note that the first thing that I'm going to do, I have to first find the output power. So let me say the output power. It is the same thing as we all know, we have the 25 megawatt. 25 megawatt multiplied by multiplied by 0.8, which is the power factor, which is 0.8. As you all know, it is the same thing as 20 megawatt. So the next thing that I'm going to do, I have to find the input power also. Let me say this is input. Let's say it is power, input power. It is the same thing as this output power. I have to divide it by by the percentage of of this efficiency, which is 0.97, and it is the same thing as 20.619 megawatt. So I have to find the losses. The losses is the same thing as, I have to say the input minus the output. 20.619, I have to say minus 20, it is the same thing as 0.619. So then I have to say the 90%, assuming that the 90% of the total losses. So I have to say the 90% of total losses dissipated by air, it is the same thing as this. This 90% will now be 0.9 multiplied by multiplied by this, which is 0.619, and it is the same thing as 557.1 1 kilowatt. So the next thing is that the heat to be remote powered per minute. So I have to find the heat to be remote powered per minute. So the next thing that I'm going to do, it says the quantity of cooling air required per minute at full load. So I just have to multiply this by 60. I have to multiply it by 60, and it will now become, let me phrase it and see, it's something like this. Yes, it is 33,000. It is 33,426 kilojoule power per minute. So the next thing that I'm going to do here is that the heat absorbed by air. As you all know, heat absorbed by air, we can use the relation Q, which is the same thing as mCp delta T. But what will be our Cp? As usual, we are going to use it says the specific heat of air, which is 0.24. It is 0.24. So I have to say the specific heat 0.24 kilocal per kg degree Celsius. It will now be 0.4. Okay, sorry, 0.24. It is 24. As I said before, kilocal, it is 1 kilocal, it is the same thing as 4186 or 4.18 what? 186. So what should I going to get? So I'm going to get the CP should now be 1.004. So then I have to say what will be my delta T, change in T. So it says the inlet temperature it says the inlet air temperature is 20 and the temperature rise is 30 degree. So I'm going to choose 30 degree as my temperature rise. You have to take note of that. So the next thing is that I'm going to say the Q, which is the same thing as MC P delta what? Delta T. I have to divide both sides by what? By C phi delta T, which is C phi delta T. This will go with this. At the end, the M should now become the Q by what? By the CP delta T, and it will now become, so what will be the Q? Q is the same thing as this, as we find, which is the heat absorbed by air, which is, but I have to clean it, which is 33,426 by 1.0446 multiplied by the change of T, which is 30. So it will now be 1109 kg for what? 5 minutes. But you have to take note that from the question, it says it talks about the volume. Yes, it says, and that of 1 kg of air occupies 0.8. So I will now say the volume, which is 1109 multiplied by 0.8. Let me see, what should I going to get? 1109 multiplied by 0.8. Wow, I'll get 887 meter cube per minute. So this is the final solution. So did we get the right answer? Yes, they have 890 meter cube. So it is almost the same thing, because 890 and 887, it is almost the same. So we have to move to the next question. So the next question says a thermal station has an efficiency of 15% and 1.0 kg of what? Of coal burned for every kilowatt hour generated. We are to determine the calorific value of coal. So I have to leave this question for you, but I'm going to solve it because it is very simple. So you have to take note of the thermal efficiency, which is 0. I'm just going to substitute direct 0.15 after converting it. As we all know, 1 kilowatt hour is the same thing as 860. So I have to say divided by our mass, which is 1.0, multiplied by the calorific value that we are looking for. So if I cross multiply I'll get this, multiplied by this, I'll get only 1. So at the end, okay, let me do it step by step. 0.15, it is the same thing as 860 by only CB. So I'll cross multiply. I'll have CB 0.15, which is equals to 860 by dividing both sides with 0.15, 0.15. This will go with this. CV, it is the same thing as 860 by 0.15. So what should I going to get? At the end, I'll get, let me press it and see, 850 divided by 0.15. Yeah, the CB, it is the same thing as 5,733 kilocal per kg. Yeah, let me check whether we are right. 5,733 kilocal per kg is our final solution. So guys, if this video is more helpful to you, please consider subscribing, commenting, liking, and do share to your learning colleagues so that they will learn more about the course electrical power, which is the steam power station. So thanks you for watching. I really appreciate. Have a nice day.